Welcome back. In this video, we are going to solve example 5.4 that is taken from chapter number 5 torsion and book name is Mechanics of Material by R.C. Hibbeler, ninth edition. So statement is a solid steel shaft AB shown in figure 5-13 is to be used to transmit 5 horsepower from the motor M to which it is attached. If the shaft rotates at W is equal to 175 RPM and the steel has an allowable shear stress of 14.5 KSI, determine the required diameter of the shaft to the nearest 1/8 inch. So you can see that this is shaft AB and that is attached with this motor M which delivers power of 5 horsepower and it rotates with the RPM of 175 and allowable shearing stress is 14 KSI. So you have to determine the diameter of this shaft which is rotating with 175 RPM. So let's start with the solution. As we know that power of this motor will be equal to torque multiplied by angular its RPM. So what we will do is that we will find this power first and we will find this power in foot per second. So let me write that power is given as 5 horsepower and we know that 1 horsepower is equal to 550 feet multiplied by pound per second. Clear? This is 1 horsepower. So I can write 5 horsepower is equal to 5 multiplied by 550 feet into pounds per second. So let's multiply this. 550 multiplied by 5 is 2750. So I can write it as 2750 pounds into feet per second. This is the power. And we know that omega, which is given as 175 RPM. RPM stands for revolution per minute. And we know that 1 revolution is equal to 2 pi radian and 1 minute is equal to 60 second. Okay, so what I can write is that 175 revolution per minute. I can write it over here. So 175, 1 revolution is 2 pi radian. So I will multiply it with 2 pi radian and divide by 1 minute is equal to 60 second. So I will get W is equal to this one. So we will just multiply this 175 multiplied by 2 pi, 175 multiplied by 2 multiplied by 3.1417 divide by 60 will give you 18.326 which is 18.33. I can write 18.33 radian per second. Okay, once you get this P and omega, so from this equation which we have written that power is equal to torque multiplied by RPM. So from here you will get this torque will be equal to power divided by W. Okay, so power is how much? 2750 pounds into feet per second divided by W is 18.33 radian per second. Okay, so you can just write it as, so second will cut and we will get torque will be equal to 2750 divided by 18.33 will give you 150.1 or 150. You can just write it as 150 pounds into feet. This is the value of torque. Now in question we have been given that allowable shearing stress is equal to 14.5 KSI, which can also be written as 14.5 into 10 raised to power 3 pounds per square inch. Okay, and as we know that allowable shearing stress due to torque is equal to T into C divided by J, where C is the radius, J is the polar moment of inertia. So let this is your equation number 1 and this is your equation number 2. So comparing these two equation, I can write T into C divided by J is equal to 14.5 into 10 raised to power 3. Okay. Now we know that J is the polar moment of inertia and that will be equal to pi by 2 C power 4, where C is the radius. Clear? And um, since we are going to find out the diameter, so just plug in this value. So I will get C divided by J is equal to 14.5 into 10 raised to power 3 divided by torque, and this torque is 150. This is 150 pounds into feet. Now from this you can also get that 150 divided by 14.5 into 10 raised to power 3 will be equal to J divided by C, and you can just plug in the value of J. So J is pi by 2 C power 4 divided by C. So this C will cancel with this. So we will left C power 3 is equal to 2 multiplied by 150 divided by this pi multiplied by 14.5 into 10 raised to power 3. And if you plug in the value of units, so 150 is actually feet into pounds. Clear? The unit of, and in below this 14.5 into 10 raised to power 3 will also have unit pounds per square inch. So what we will do is that we will convert this feet into inch. So for that we know that 1 feet is equal to 12 inch. So I will multiply as 12 inch divided by 1 feet, as 1 feet is equal to 12 inch. So what you will get is that final you will get this C cube will be equal to 2 multiplied by 150 multiplied by 12 divided by pi multiplied by 14.5 into 10 raised to power 3. Clear? And let's calculate this. So I will take it 2 multiplied by, let's move this calculator. Okay, 2 multiplied by 150 multiplied by 12 divided by pi 3.1417 multiplied by 14.5 multiplied by 1000, and you will get this 0.079. So let me write it. C cube is equal to 0.079, and if you take the cubic root, so this will be equal to 0.079 cubic root, and let's take the value of cubic root. Let's shift this. So 0.079. Let me check the value. This was 0.079. Yes. So 0.429, or you can say this C will be equal to 0.429 inch. Okay. Now once you get this C, so we know that diameter of this shaft is equal to 2 times radius, where C was radius. So 2 multiplied by 0.429 will give you this diameter will be equal to 0.875 inch. Now we have been asked to determine this diameter of shaft to nearest 1/8 inch. So you can see that 1/8 inch is how much? So I can find 1 divided by 8 is this one. So if I multiply this with 7, so 7 by 8 is, or you can write 7 divided by 8 is also 0.7875 inch. So the final answer will be equal to 7 by 8 inch. You can also write 0.875 inch, and you can also write this as 0.875. Both are correct. And this was all about this example 5.4. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.